Okay, so basically, well, right now we're starting two variable data with the correlation coefficient. In data analysis, we often try to determine whether one variable, the dependent variable, right? The dependent variable goes here, and the independent goes here. So your x goes here is your independent. So you would think that your y value depends on your x value, and it should always look like that. Okay, we try to determine whether one variable is affected by another variable. The independent variable is a variable whose value is arbitrarily chosen, and the dependent depends on the independent. The scatter plot shows such relationships graphically, usually with the independent on the horizontal and the dependent on the vertical, just like I said. So, these are two dog training systems, the Rogers method and the Lang system. Okay? So we're going to see maybe which one gives us more consistent results. And yeah, maybe a ruler at this time would be good. It might be just nice to draw a more solid. We'll use that as our axis right there. Okay, so there's these two choices in dog training systems, the Rogers method and the Lang system. Right? The dogs were randomly selected from 5 to 16 hours of training in one of the two training programs. The dogs were assessed using a performance test graded out of 20. Okay? So notice the score. You would think the score depends on hours of training. So hence the score is the y variable. So we can go up by, each one represents one starting at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And hours of training will go up. Each one is worth 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? So, at 10 hours of training, the score was 12. 11, 12. At 15 hours of training, the score was 16. At 7 hours of training, the score was 10. At 12 hours of training, the score was 15. At 8 hours of training, the score was 9. At 5 hours, 8. At 8 hours, 6, 7, 8, the score was 11. At 16 hours, the score was 19. And at 10 hours, the score was 14. So it should look something like that. So if you were to look at this, you could kind of see as hours of training goes up, the score seems to go up. As hours of training goes up, the score. That's what you want to see, right? It'd be terrible if hours of training you go up and the score goes down. Okay. So let's do this guy, the Lang system. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, Okay, so at 8 hour, I'll keep quiet. I'll just let you graph. But at 8 it equals 10. At 6 it equals 9. At 15 it equals 12. At 16, at 16 it equals 7. Oh boy. That must be Spencer, my golden retriever. At 9 it's 11. At 11 it's 7. Actually, my dog Spencer is very treat motivated. He'll do anything for a cookie. He's kind of really cute, actually. At 10 it's 9. 10 it's 6. And 8 and 15. That's kind of all over. Oh, I think I made a mistake. 8 and 10, that one's right. 6 and 9, that one's right. 15 and 12, that one's right. 16 and 7, that looks right.
9 and 11?
9 and 11? Oh, that should be up there? That looks better.
For the first chart, is there one at 15 and 16?
Oh, what is it? 15,
No, the first
15 and 12.
the Rogers method.
The Rogers method? Which one?
15 and 16?
16 and 19?
No,
I guess I'm not, you know what, I'm hard.
no.
Oh, you know what, I'm not even recording. I don't have my headphone on. Did I? Just let me, hold it a second. Sorry, what was Oh my, I forgot to put on the equipment. What was your question before I put it on?
15 and 16.
The one at 15?
And it's at
Oh.
16.
Oh, it should be 16. Thank you so much. You know, I am very hard of hearing. Okay. I hope this, sorry out there in internet land, I forgot to put on the headphones. Do you think maybe I should just start over? Okay. All right, I won't. Okay, what happens here is hours of training goes up, what happens? Yeah. So as hours of training goes up, the score changes randomly. So are we good so far? I'm not sure I am. I just hope you guys are. Okay, notice for the Rogers method, as hours increase, so does the score. There appears to be a positive relationship between hours and score. For the Lang system, hold it, I just have to check something. For the Lang system, as hours increase, his score changes randomly. No relationship appears. So, the scatter plot is a visual tool for identifying the relationship between variables. This is only a rough indication. A more precise way of measuring correlation is this correlation coefficient. So start memorizing it, guys. No, not right now. Um, so this correlation coefficient is a more precise way of determining how closely do these points fall on a line. Okay, so it has funny values though. Okay, so that's what I want you to talk to you about. So for example, the correlation coefficient, the value is between -1 and 1. It's never -2 or -1, like it's always between -1 and 1 and anything in between. It doesn't go below -1. If it does, if your correlation coefficient goes below -1, you have a calculation error. If it goes above 1, you also have a calculation error. So for example, when it's between -0.33 and positive 0.33, the correlation is weak. As it gets closer to either -1 or +1, it's very strong, it's perfect. So just as an example, if you have a scatter plot and all the points fall on a line, your R equals 1. And it doesn't matter what the slope is, R equals 1. Now, if there isn't, the only thing you can tell from the R whether it goes upward to the right, if it's a negative value for R, it goes downward to the right. So here, R equals -1. Okay? If you have something like this, R is approximately equal to 0. If you have something like this, and some points are like that, then R might be approximately 0.9. Just to give you a rough idea. This would be close to 1, but it would not equal 1. So we're going to actually calculate it in a few minutes. The correlation makes no distinction between the independent and dependent variables. That just means if you were to accidentally put X here and Y here, and then I guess, well, I think they'd be inverses of each other, R would equal 1. Right, for both of them, even though you got the x's. So that's what they're meaning here. Correlation makes no distinction between your x and y. It makes no difference which variable that you call x or what variable you call y. It makes a difference to the equation you're going to be calculating. Positive R indicates positive association. So as x goes up, R goes up. The negative R indicates negative. So as x goes up, R goes down. Y goes down. The correlation R is always a number between 1 and -1, as I was saying. Values of R near 0 indicate a very weak linear relationship. The strength increases the closer it's either to -1 or +1. Do not confuse R with the slope of a line. They are two different things. Correlation measures the strength of only the linear relationship between two variables. Do not use R. Do not use R for curved relationships. A strong R does not prove cause and effect. Strong R does not prove cause and effect. So for example, if we were to go back here, do you feel that the Rogers, which one would have a stronger R? The Rogers, right? Because this seems to fall on a straight line. Do you think we have proven as hours of training goes up, the score goes up? We did not prove it. Why is that?
Because what this data is giving us is that it only tells us that the amount of hours put in and the score that the dog got after those hours. And if you were to compare the two of them, you would just be told that the lane system is just worse than the Rogers method.
Yeah.
And you're not actually saying that the dog can perform better because it learned more, it understood the material more, or etc. etc.
Okay. So these are the variables we're studying, but what other variables might affect this? Yeah. Okay, so what's the name for that? Extraneous variables, right? That's why we haven't proved it. So some extraneous variables are the breeds. Some breeds are known to be smarter than others. It could be the trainer, right? It could be, did they have previous training? So there's a lot of extraneous variables. I think my dogs train me better than I train them. I'll call my dogs to come. I go, Champ, come, to come back into the house. He won't come in. And then I yell, Cookie, and he comes running. Give him a cookie and he'll do anything. Okay, so let's actually calculate these guys. We're going to do that here. Okay. So, I'll do the Rogers and I'll have you do the Lang system. So, x squared 100 so this is quite a kind of a tedious exercise, but what can you do? When you do your projects, the computer will calculate it for you. Y squared and that's 196. XY is 120. 15 times 16, 240. This is 70. 12 times 15 is 180. 72. 40. 88. 16 times 19, 304. And that's 140. We're going to need a running total. So sum of x equals 91. Sum of y equals 114. Sum of x squared equals 1027. Sum of y squared equals 1548. And sum of xy equals 1254. So these are the sums we need in order to do this calculation. So now this is one of those formulas, again, that has quite an extensive proof. However, it's beyond the level of this course. You just have to memorize the formula. I know some of you like to know these things, but so let's plug it in. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 points. Sum of xy is 1254. And minus sum of x is 91. And sum of y is 114. All over the square root, you're going to have two brackets here. N times sum of x squared, 1027, minus 91 squared. It's going to be 9 times sum of y is 1548, minus 114. So if you were to calculate that on the top, you'd get 912 over 962 times 936. And that is about, so on the test you're going to do it to 4 decimal places. So we just want to classify this. I kind of just went through that quickly. It's just a number crunching exercise. However, we got now an R of 0.9611. So if you were to take it to the chart, notice that 0.9611 falls there. So if you were to classify it, you would say it's a strong positive linear correlation. Strong positive linear correlation. What do you think the Lang one might be? Close to 0? Not sure, but it's hard to tell whether it's positive or negative, right? It could be going this way or that way. So I want you guys to do this. You can to calculate R. The answer is, just get practice using that formula. The answer is that, and the classification is weak, negative, linear correlation. Okay, that's your answer. You just get that. You give it a try. If you have any problems with that formula, let me know. I can even, well, I'll let you calculate them, okay?